Renowned computer scientist Professor Hermann Koppetz is one of the co-founders of TTTech and the architect of the time-triggered technology that lent the company its name. In 1997, 1 year before TTTech took up its operations, he published his groundbreaking work, Real-Time Systems: Design Principles for Distributed Embedded Applications. The book is now being used at universities as a standard text all over the world and went into its third edition in 2022. Today, it is my pleasure to welcome Professor Koppetz himself and Dr. Wilfried Steiner, director of TTTech Labs, who co-authored the third edition. Together, we will explore the origin of this revolutionary work and trace its impact on research and industry throughout the past 25 years and into the future. Professor Koppetz, I'm very happy to welcome you here today. You were working in industry before going into academia. What did you experience there that inspired your scientific work?
Well, I worked in industry as a department manager for computer process control. And we had a number of very interesting projects to accomplish all over the world, particularly one in South Korea and in Mexico. And I was a bit astonished and amazed that at that time, the design and the implementation of real-time embedded systems was more of an art than an engineering endeavor. Mm-hmm. That means you tried as good as you can to build something and then hope that it will do what it was supposed to do. Mm-hmm. So when I had the chance to go to the University of Berlin in 1978, I decided to work to establish some foundational principles, how to design real-time system systematically and not only by trial and error. And we found out that the most important issue is that you have a clear notion of time. And time is something very special in our life. It proceeds every day, by the second, by the minute, by the day. And in computer systems that are normally built, time plays no role. Normally you just try to get the correct output from the given input. But in embedded control systems, for example, if you wanted to control an automotive engine, you need to control the precise moment when you output a signal. In automotive control, it's, for example, in engine control, it's in the order of microseconds. Mm-hmm. And how to deal with this issue of precise temporal behavior requires a new design technology, a new consider time as a first-order citizen. And this is why we came to the idea of time-triggered. But the most important achievement of the first 10 years at the university was to come up to a global time base which is fault tolerant. That means if you base your system actions on the progression of time, a loss of time would mean a failure of the system. So you must build a time base that will continue even if some parts of the system fails. That means you need at least 4 clocks, and if one of the clock fails, then you still must maintain a time of desired precision in order to get the output on time. And this issue of building a fault-tolerant time base took us about 10 years, I think. Wilfried was one of the students who came to the university, and we already were quite a bit ahead. And we developed a new communication protocol among these distributed systems, which house the different clocks, the time-triggered protocol. Mm-hmm. And if you now look into the internet, into Wikipedia, you find at least 5 or 10 pages about the time-triggered protocol, because it was the first protocol that integrates a number of services like clock synchronization service, membership service, reliable data transmission in a single protocol.
Very interesting. And Wilfried, can you explain in simple terms how your first contact with the subject of embedded systems was?
Yeah, of course. So as Professor Koppetz said, I was a student in 1996, and so the major work about TTP was already concluded by then, and the book, I think, came out in 1997. So as I was a fresh student, and I was very lucky to have Professor Koppetz as a professor at TU Wien. And Professor Koppetz was teaching not only real-time systems and embedded real-time systems, but also operating systems. And very early in my studies, Professor Koppetz pitched the subject of real-time systems very much. And I was intrigued by that problem, as Professor Koppetz said. So it's not just like in regular IT, where it's important that the outcome of the operation or the outcome of the computation is correct, but it also has to be delivered at the correct point in time. So I thought that's a very interesting problem to work on, especially as Professor Koppetz says, if it doesn't work like that, if the result is not provided in time, that would mean potentially catastrophic consequences. Like in a car, the engine breaks down, or like in an airplane, something catastrophic could happen. Mm-hmm. So I thought that's a good problem to spend a career on.
Mm-hmm. Professor Koppetz, how did the first edition of the book originate?
Well, the first edition of the book originated out of a series of lectures which Wilfried mentioned. I gave and I had notes, and then I decided to put the notes together into a book. But then, of course, English is not my native language, so I needed somebody who would look over the book from an understanding and English point of view. And I had the chance to become a visiting professor at the University of California in Santa Barbara. And I gave a course there, which was a very different course, because I gave to the students chapters of my book and asked them to correct them. So they were correcting my work. And this is how we improved the English and the understandability of the book. And in this first edition, some of the students who did excellent work in Santa Barbara are even mentioned there in the first part. This is how it originated.
And I saw that you brought your book as well to us today. Could you show us the first edition?
Well, this is the first edition. This was done with Kluwer Academic Press. And Kluwer was then later on acquired by Springer. Mm-hmm. So now the second and third edition are with Springer. And the first edition was trying to capture the essence we knew at the time. Mm-hmm. But as you know, information technology is moving quite quickly, and you have to be careful to keep up with the state of the art. So this is why then in the second and third editions there have been some major additions and deletions.
Absolutely. You just mentioned the second edition. The second edition came out in 2011. What was the motivation for the second edition?
Well, the motivation for the second edition was, first of all, Springer asked me to do a second edition. and secondly, there have been a number of changes in the field. For example, the whole area of Internet of Things became very important. So I had a new chapter in the second edition on the Internet of Things. And furthermore, two topics which always have been of importance, but which grow even, the importance grows even now as time goes along, is simplicity or complexity, one, and the other one, security. Mm-hmm. I think security, complexity, and safety, of course, are now more important than 20 years ago, because the systems are employed in machines, in robots, and in cars, where a failure of the system could cause harm to the human. And so safety, security, and simplicity, and they go hand in hand, get more importance, and we put the new chapter on simplicity in the second book, in the second edition.
Very interesting. Wilfried, I'm sure that you also studied the second edition thoroughly. In your opinion, how did it respond to the new challenges that arose in the industry at that time?
Yes, of course. I studied it very much in detail, of course. And as Professor Koppetz said, one of the focus points that was addressed in the book was now how to design complex systems, or better said, how to design a system such that it's not getting complex in a sense that we don't understand it anymore. Mm-hmm. So it targets really the question, how can I build even large systems, but simple enough such that I can understand it, or an expert can understand the system. That was one of the major achievements of the book, to address this topic from a scientific perspective. The other one that's probably more industry or directly industry applicable or relevant was a new chapter on, or an updated chapter on real-time communication. Mm-hmm. And during the years, we have seen a need that from the original time-triggered protocol, industry was looking for a protocol that was able to communicate more data. Mm-hmm. And at the time, between, actually at the time during the two books, a lot of research went into developing or finding out how could you use an Ethernet-based protocol in a time-triggered fashion, and thereby getting a time-deterministic delivery of messages on the network, but also to be able to use the network not only for real-time, critical real-time communication, but also for non-real-time or non-critical communication. So the TT Ethernet chapter was also added in the second edition, and this was exactly the time when we at TT-Tech also developed the first TT Ethernet products, and also when the TT Ethernet standard was being published or has been published. And I believe even in this book already, in this edition, the second edition, it's already referenced that TT Ethernet was already baseline for the NASA Orion spacecraft.
Thank you, Wilfried. The most recent edition from the book is from October 2022. Professor Koppetz, what did change in this third edition?
Well, there have been, as was already mentioned before, very important developments in the area of communication and internet access and internet activity. More and more machines, real-time machines, were connected to the internet in order that you could control them remotely, that you can look at the data remotely. And so the whole issue of internet activity and real-time activity is a focus of this new chapter in the second edition, because in the time it takes to send a message to some remote data center is sometimes too long for a real-time action to be finished on time. So you need to be careful that you have some activities which are very time-critical locally, and some activities which are not so time-critical you can output to the internet. And so the whole idea of fog computing and network interfacing came up, and this is, I think, a very important addition in the third chapter, in the third edition of the book.
And how was the whole process for you creating the third edition?
Well, I had a lot of support from Wilfried, because he was working in this area of real-time communication and fog computing and networking and interfacing to the internet. So this important new edition is mostly his work.
So as a co-author, Wilfried, this is something you can be definitely proud of. How was your experience?
Oh, I was definitely deeply honored by the opportunity to work as a co-author and to contribute two new chapters. The one being on fog and cloud computing or edge computing, and the second one to rework the section or the chapter on real-time communication. In terms of real-time communication, again, in the time span of like 10 years, a lot of things happened in the industry and technology-wise. And one of the core and fundamental changes has been that the time-triggered paradigm that has been researched by Professor Koppetz over maybe the last 50 years, and then has been put into the first edition of the first edition of the book, that has now been transferred through the TT Ethernet technology and products that we offer into a mainstream IEEE standard. So I found that very astonishing that on the one hand, that a fundamental paradigm has the opportunity, has the possibility to actually make it into mainstream standards. But then on the other hand, it's also kind of surprising that it takes so long, like 50 years from an original basic idea until it becomes a IEEE standard. So yeah, it was excellent to have the opportunity again to work through all the chapters, and the information density in this book is extremely high. So you see that every sentence is handcrafted. A lot of thinking went into what is the right amount of detail, such that you get directly to the point. I think it's also one of the reasons why the book is so small, so slim actually, and it's not the reason is not that the book doesn't contain a huge amount of information. The reason why the book is probably 300, 400 pages and not 1,000 pages, is the level of abstraction that went into crafting the text is so extremely good. And that kept, also that level of information, that writing style, kept its nature throughout the editions. And I tried my best to keep up with the writing style from Professor Koppetz, which I said was quite demanding. I should add, I was also surprised in the beginning now that Professor Koppetz said that the first edition, for this one, he was not a native speaker and had the support of students in the US. Well, I can maybe just comment that me as a fresh student coming with the high school English from 25 years ago, it was also not very easy to read it.
Now, Professor Koppetz, considering the evolving landscape of technology, if a fourth edition were to be published next year, what new elements or updates would you consider incorporating?
Well, let me say this. We published the second edition after about 10 years, the third edition after 10 years. So a fourth edition would also be 10 years from now, not next year. And in 10 years, a lot of things can happen in the information technology sector. And I think we have to look what's happening and then decide maybe after 8 years what has to be put into the book. But I can see now already one area, for example, the area of deep convolutional networks for data-driven computing in neuromorphic computing. That definitely is going to be one chapter in the next edition. But let me say this, we tried, although not fully successful, to put relevant information into the book, but don't make the book look much with many more pages. So you always have to take out something. Mm-hmm. And taking out something is even more difficult than what you take in.
Absolutely.
And so I think we succeeded in taking some things out of the previous editions. And if somebody really wants to get more information on that, he can go to the previous edition to find it. And so the third edition, I think there will be something of these neural networks and machine learning. And another area which is getting more and more important is this issue of safety and security and simplicity. Mm-hmm. And I think there's already a chapter in there, but we would expand this chapter, I think.
Mm-hmm. And following up on that, Wilfried, as we navigate through the age of AI and increased autonomy of machines, what role do you believe real-time systems play in shaping and responding to these advancements?
Well, I think that when it comes to AI, we need to be very careful not to jump on the hype bandwagon, kind of. So we need to have a solid technical understanding to make a judgment whether a development in AI is relevant for real-time systems or not. And as Professor Koppetz said, it's clear that some of the developments are relevant. And we also see that by experience in the TT Tech company. We have successful trade studies or studies going on that show already today that AI or machine learning-based systems can be used in order to simplify and improve the efficiency in development processes. On the other hand, we also know from the industry that AI-based systems using machine learning for the perception system, that those systems are essential to realize perception. To give, let's say, an autonomous car the ability to understand, or probably not to understand, the ability to realize which objects are surrounding that car. And these machine learning-based systems are doing that task much better than more traditional technologies. So in that sense, for these subsystems, in real-time systems, it's rather clear that AI-based technologies, they are to stay. And as Professor Koppetz said, I think that's a very good new chapter, new information to be put into the book. But then the question is, again, how do you condense this huge body of information on AI-based systems, machine learning-based systems, into a chapter to be put into this book such that it's on the same level of writing style and information content.
Thank you very much, Professor Koppetz and Wilfried, for this insightful discussion and overview. Summing up, I believe it can be said that real-time systems have an eventful history and will remain part of major industry developments in the years to come. For more news and content, head to our Impact25 website, tttech.com/impact25. Impact 25 and check out our virtual time capsule. Thank you for watching.